Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 13th, 2026, just 1 week ago. It presents a comprehensive study showing that while human-curated skills boost agent pass rates by roughly 16 percentage points, self-generated skills offer virtually no benefit at all. The paper is titled, SkillsBench, Benchmarking How Well Agent Skills Work Across Diverse Tasks. And as we'll see shortly, the results suggest that smaller models, equipped with the right skills, can actually rival much larger models. Figure 1 visualizes this framework with a helpful analogy at the top. It treats models as the CPU, the agent harness as the operating system, and skills as the applications running on top. The bar chart below then quantifies the impact across 7 model configurations. The solid bars demonstrate that adding curated skills consistently boosts resolution rates, often dramatically, as seen with Opus 4.5. However, the hatched bars show that self-generated skills provide almost no improvement over the baseline, confirming that models struggle to author their own procedural guidance. To understand what strictly defines a skill in this context, Table 1 contrasts them with familiar approaches like prompts, retrieval augmented generation, and tools. The critical differentiator appears in the second row, procedural guidance. While retrieval augmented generation fetches facts and tools provide capabilities, neither explicitly teaches the agent the method for solving a task. Skills fill this gap by combining that procedural know-how with executable resources, making them the only paradigm that satisfies all 4 criteria for autonomous agents. Having established those definitions, Figure 2 outlines the end-to-end pipeline used to build this benchmark. Phase 1 begins by aggregating a massive pool of over 47,000 unique skills and collecting over 100 community-submitted tasks. Next, Phase 2 acts as a rigorous quality filter, applying both automated checks and human review to narrow this down to 84 high-quality tasks. Finally, Phase 3 handles the evaluation, running these tasks through agent harnesses like Claude Code or Gemini CLI to generate thousands of trajectories for analysis. So Figure 3 details the final composition of those 84 tasks, breaking them down across 11 distinct domains. Software engineering dominates the set with 16 tasks, followed closely by office and white-collar workflows. However, the benchmark intentionally includes a long tail of specialized fields, such as robotics, manufacturing, and healthcare. This diversity ensures that agent skills are tested not just on standard coding problems, but across a wide spectrum of real-world professional scenarios. With the tasks defined, Table 3 presents the primary performance benchmarks across all 7 model configurations. The central columns highlight the impact of curated skills, where we see the average pass rate jump significantly, from roughly 24% to 41%. Gemini 3 Flash combined with the Gemini CLI takes the top spot, reaching nearly 49% success. However, the rightmost columns reveal that self-generated skills largely fail, yielding a negative normalized gain on average. This validates the hypothesis that while models benefit immensely from human expertise, they cannot yet reliably synthesize that procedural guidance on their own. Moving beyond raw accuracy, Figure 4 plots the cost-efficiency landscape, comparing pass rate on the vertical axis against average cost on the horizontal axis. The key visual is the separation between the 2 frontiers. The dashed red line for with skills sits consistently higher than the dotted blue line for without skills. This upward shift implies that skills allow cheaper models to punch above their weight class. For example, Gemini 3 Flash near the top center rivals the expensive models on the far right while remaining significantly more affordable. So, while the previous figure established efficiency, Table 4 reveals exactly where those gains come from by breaking down performance across 11 domains. The top rows show a striking pattern. Specialized fields like healthcare and manufacturing see massive improvements, jumping by roughly 52 and 42 percentage points respectively. This suggests skills are most critical when procedural knowledge is rare. Conversely, looking at the bottom rows, commonly pre-trained domains like software engineering show much smaller gains, implying models already know these workflows well. Wrapping up, SkillsBench demonstrates that human-curated skills are a potent tool, enabling smaller models to match the capabilities of much larger ones, yet the inability of models to author these skills themselves highlights a critical gap. Human expertise remains essential for defining workflows. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.